Goldman, who is CEO and co-founder of Biotic.
So microplastic is already found in human blood, so it's no longer just an environmental concern. And with only, like mentioned here, with only just few percentages of plastic being recycled globally, the rest ends up in landfill and find its way to our natural resources, and we end up consuming a spoonful of plastics every week through our food, air, and drinks. I'm Goldman. I'm the CEO and co-founder of Biotic. And we envision a world where plastic is no longer a concern, in which the consumer, us, purchase the product in the exact same way. And after use, we just toss it away to any trash, and the product will fully biodegrade without the need to sort, recycle, or worry about it. Biotic provide a fully bio-based circular PHBV polymer manufacturing process using marine biomass as feedstock to our precise fermentation process, targeting to produce polymer flakes or pellets to replace plastics. We use seawater in our process in order to reduce cost and eliminate contamination risks, and we have achieved non-sterile continuous fermentation that enabling us scaling up processes and reduce cost to achieve our goal and targets. We target to achieve a polymer that will fit existing production line so that producers will not need to change their billions of dollars existing manufacturing facilities, but also from the consumer point of view, have the same look and feel so that we can still feel and use the plastics that we are so happy to. Secondly, we want the polymer to be cost competitive to fossil-based plastics, and having the processes that I mentioned before allows us to look at price reduction to achieve that. And finally, of course, the product fully biodegrades in any environment. It doesn't matter where it gets, it fully biodegrades back into CO2 and water. Our products fit a wide range of application, and we target to work with corporate companies in order to achieve seamless transition. Our copolymer can fit anything from very ruggedized products to very flexible products and anything in between. And we can do that by controlling the characteristics of the copolymer. And it can fit anything from tables to packaging to textile, wearables, electronics, and anything else you can think of. We are working in our lab, scaling up our production, aiming to have a fully operated industrial scale facilities at the end of 2025. And our business model looks at selling our biological polymer and byproducts as commodities, sub-licensing the technology to partners around the world to expedite our production capabilities, and finally, continue the collaboration with corporate partners in order to provide more and more solutions as the industry will need. Our team shared the passion for the environment, and we bring extensive experience from different fields, including marine biotechnology, metabolic engineering, scaling up, regulation, and business. And we're doing everything that we can so that we can provide an inclusive and an innovative solution that will fit as much as possible to the market. We have achieved few scaling up processes in our lab, and we are currently working on a seed round to enable our pilot plant to expedite our production capabilities to hundreds of kilograms, achieving market validation with corporate and we also have opening for additional corporate pilots for you guys. So if you are interested to hear more about our seed round or collaborate around the pilot, please reach out to me. Happy to provide more information. Thank you very much for having me again.
So happy to go first question. So you mentioned a wide applicability of corporates that you could work with. Having any testing on the material properties needed to get access to those corporates and what they require from you as a technology?
Well, it depends on the application. So if you look at flexible application, there is different requirements. If it's just dry food packaging, there is one requirement. If it's freezer packaging, it's a different requirement. So we have a set of requirements for multiple partners that we work with around the width of the package or the size of the box. And we have a list of analytics that needed to show water-vapor transition, barrier rates, and such, so that we can confirm with those customers that it fits what they need. Also, of course, commercial-wise.
Thank you.
Adi, I think you've got a room of corporates and investors here, and maybe a question is around how you scale this company and how you get to the point in time when you can supply some of the large groups here, and that requires investment before that. So tell us how you think about the steps in your journey to scale this, and how you can demonstrate to everyone in that value chain that this can be a technology to sustain itself.
Yeah, well, when we first started it, so we got to this with a regular approach towards fermentation and bioreactors and all the cost that surrounds it. We did that, and we did the scaling up with that, and we still understood that cost-wise, this is very expensive, right? We need to achieve something that is much cheaper in the process and much cheaper in the energy consumption. So our process works, but scaling up is going to be still expensive. So we've actually built our own fermentation vessel, reducing the capex cost on the bioreactor, let's call it, to a tenth approximately of the price. So basically we can do, and we built it in a modular way, so we can scale up the production really quickly. We had a 25 liters bioreactor or fermenting vessel working up until 2 weeks ago, and within about 2 weeks we scaled it up to about 200 liters within a few days. So this is one aspect. Based on that, and based on the fact that we're using seawater, which is also reducing a lot of the energy cost behind it, non-sterile and continuous fermentation enabled us to expedite the capabilities, enhance the production capabilities, and altogether reduce the time of the production processes. And energy-wise, we did an LCA to compare the bioreactor or the common fermentation that we did before, compared to the fermentation that we are doing today, the same sizes, reduced the energy consumption by 70 to 90%, depending on the sizes. And as we scale, we have room to increase efficiencies in our production, so our entire process efficiency will be even greater and bigger than it is today, so scalability will be easier from that aspect. Also, partnerships, we are working to open the roads to partnership in terms of suppliers of algae, but also suppliers of other resources around the world. So as we need, it could be localized, it doesn't need to ship anything. The algae that we are using is fresh algae, so we don't need to ship dry algae, which doesn't make any sense. And everything could be done much easier at the location.
Thank you.
Thank you.